Okay, so when you're simplifying radicals, the first thing you want to do is have either memorized in your head or literally physically written down on a piece of paper this list right here of perfect squares. The more comfortable and familiar you are with these perfect squares, the easier this process will be. So you need to know that if you are taking the square root of a number that is not a perfect square, you're going to end up with an irrational number. An irrational number is a number that cannot be written as a fraction. Why can it not be written as a fraction? Because it has decimals that do not repeat and they do not terminate. We have a trick for taking repeated decimals and changing those into a fraction. But if they do not repeat and they do not terminate, that means they go on forever, then we are not able to rewrite that as a fraction, and it's called an irrational number. You can the Most people do not have an intuitive sense of the value of the square roots of these numbers. Most people think that the square root of 2 is probably somewhere close to 2. And while you're not far off from wrong right there, most people do not have any idea that the square root of 82 is a number that's very close to 9. So I'm going to give you a trick for thinking about this. The trick is think about all the numbers, the 1, 2, 3, 4, 5, as the square roots of their perfect squares. So in other words, think of 1 right here as the square root of 1. Think of 2 as the square root of 4. So when you're putting the numbers on the number line, writing down the perfect square, the square root of the perfect square right underneath it will help you place these numbers that are not perfect squares kind of in the right location. So 1 is the square root of 1, 2 is the square root of 4, 3 is the square root of 9, 4 is the square root of 16, 5 is the square root of 25, 6 is the square root of 36, 7 is the square root of 49. What I'm telling you right here is that 8 and the square root of 64 have the same value. It's kind of like having quarters and a dollar bill. You have 4 quarters or 10 dimes or 20 nickels. That's the same thing as having $1. So what I have right here is a value just written in 2 different forms. Okay, so I have an 8 and I have a square root of 64, but they have the same value, and its location on the number line is right there. So if I want to figure out where the square root of 2 is, since 2 is not a perfect number, a perfect square, I find the perfect squares that this number is between. So 1 and 4 are perfect squares, and 2 is a number somewhere in between there. Okay, so 1 right here, think about 1 as the square root of 1. Think about 2 as the square root of 4, and the square root of 2 is somewhere between the square root of 1 and the square root of 4. Now it's a little bit closer to the square root of 1. 2 is a little bit closer to 1, so it's going to be somewhere a little bit closer to 1 than it is to 2. So that's where we located the square root of 2, because it has to be between the square root of 1 and the square root of 4. The square root of 82 is going to be somewhere between the square root of 81 and the square root of 100, because the number 82 is between these two numbers. Now it's really close to that 81. It's really close to that 9. So the square root of 82 is going to be pretty close to the number 9. So there, that's a dot. That's about where. And if you go to a calculator and type that in, I think I have one open right here, and you type in, give it a chance to open. Come on, open. And you type in the square root of 82. See, it's 9.05. So it is a number that's really close to 9. So we've placed it correctly on this number line. 12 falls between right here between 9 and 16. So 12 is going to, the square root of 12 is going to fall between the square root of 9 and the square root of 16. Well, the square root of 9 is 3, the square root of 16 is 4. So the square root of 12 is going to fall somewhere between 3 and 4. And I think it's about evenly placed. So if we go back to the calculator and look, the square root of 12 comes out to be about 3.46, so that would round to be 3.5. So it should be kind of right there in the middle, 3.5. So this last one that I did right here, the square root of 8. 8 is going to be between 4 and 9. 8 is going to be between 4 and 9. It's going to be closer to the 9. So the square root of 8 is going to be somewhere between the square root of 4 and the square root of 9. Square root of 8 is closer to the square root of 9. So here's the square root of 9. It's at 3, so right before the 3. And then if we go back and look and see, the square root of 8 is 2.8, about 2.8. So we were right in saying it's about 2. There's 2.5 right here, so that's probably 2.8. And you can do the rest of these for practice. So that's kind of placing them on the number line, because you need an intuitive idea of what the value of that number is, because we are going to be, when we're finding, when we're solving these quadratics, that's what we're going to be doing, is looking for x-intercepts, and that's going to be, the square root of 2 is going to be one of the x-intercepts. We talked about 2 different methods to simplify these. The method is when you just take the factors of 20 and be sure you factor 20 using one of these perfect squares. Not every problem will factor. No, if it can simplify, then you should be able to find one of these numbers that's a factor of the number that you're trying to simplify. Because if it doesn't have one of these factors, then it doesn't simplify. So if it can simplify, you will be able to find one of these perfect squares that is a factor of the number you're trying to simplify. So 20, we go down this list and we want to find the biggest one of these. If we don't find the biggest one, then we complicate the simplifying process. But we take 20 and we change it to factors of 4 times 5. We can separate that multiplication and put the radical symbol around each one of them individually. Why do we want to do that? Because we can then say the square root of 4 is just 2. And then the square root of 20 simplifies to be 2 square roots of 5. And you can check that by saying the square root of the square root of 20, get a decimal value, and then ask what the decimal value of 2 square roots of 5 is, and it should be the exact same decimal value. So you can do this on the calculators that are in the classroom, or you can do it using a calculator on Desmos. Either one will be fine. If you're doing it using prime factors, then what you want to do is you want to do a prime factorization tree. So you just keep factoring until you can't factor it anymore. So 20 is 4 times 5. But then this 4 will factor again down to 2 times 2. So you end up with factors 2 times 2 times 5, which gives you 20. So now you go through those prime factors. You don't include the ones that have factored. So you only get the prime factors. And then if you have for every pair of prime factors, that pair, whatever it's a pair of, that number gets written on the outside, and then those things that don't pair up, they have to stay underneath the radical. So I had a pair of 2s, so I have 1 2 on the outside because I had one pair of 2s, and then I had a 5 that didn't pair up with anything, so it stayed inside. Go back to this one over here, find one of these numbers on this list of perfect squares. That's factors of 200. You want to be sure you pick the biggest one. That's 100 times 2. Separate it. The square root of 100 is 10, and then the square root of 2 doesn't simplify anymore. Okay, so that's using a perfect square as a factor. If you want to do a prime factorization, you just start off by saying, okay, 200 is 2 times 100, 100 is in 4 times 25, 4 is 2 times 2, 25 is 5 times 5. I have my prime factorizations, 2 times 2 times 2 times 5 times 5. You multiply all those together and you're going to get 25. So now you find your pairs. I have a pair of 2s, so I wrote that down. I have a pair of 5s, so I wrote the 5 down. And then I had this 2 that didn't pair up with anything, so it had to go inside. Every one of the final factors has to be included in this up here. The pairs get written on the outside, and then the ones that don't pair up, those go on the inside. And then because we multiply 2 times 5, we get 10. Same answer either way. I don't care which method you like better, just be able to do one or the other. The last example we're going to look at is this one. 48 is 16 times 3. The square root of 16 is 4. And the square root of 3 stays the square root of 3. Or you can do 6 times 8, and then 6 factors 2 times 3, 8 factors 2 times 4, 4 factors 2 times 2. We have a pair of 2's, so this pair of 2's goes right here. We have this pair of 2's, so that one goes right there. And then we had this 3 that didn't pair with anything. So 2 times 2 is 4 with the 3 that didn't match up with anything. And that is simplifying radicals.